Yo, what is up guys? Welcome to my first ever YouTube video. Today we're going to be taking a look at limits in calculus. So you're going to see on your homework, you're going to see stuff like, oh, x, and then an arrow, and then another number. Maybe, yeah, my question mark looks like a 2, so you can use 2 as an example. You can use 0. But what does this mean? So essentially what we're doing is trying to find what happens as a number approaches another number, not actually reaches it. Now what I mean by this is that if we plug in the number 2 here, so x is approaching the number 2. So let's find the equation x squared minus 4 over x minus 2. If we plugged in the number 2 to this equation, we're going to see that it's equal to 0 over 0. So let's plug it in. 2 to the power of 2 is 4. And then we have 4 minus 4 over 2 minus 2, which is equal to 0 over 0. So anytime we plug in the limit to any of these equations, no matter if it's a fractional equation or a polynomial, it's going to equal 0. But what if we simplified it further? So now we have x is approaching 2, and then we're going to try and simplify it before plugging it in. So let's take the square root of x squared minus 4. And since this is a negative number over here, we're actually looking at a fractional, or we're looking at a difference of squares. So we're going to have two numbers over this fraction. So x minus 2, because the square root of 4 is 2. And then we have x plus 2, again, because the square root of 4 is 2. So we have plus 2 and minus 2 right here. And we're going to put that and just bring x minus 2 over here. X minus 2. Now I spy with my little eye something that is the same as another thing in this fraction. So we have x minus 2 and x minus 2. And as we know, any number divided by another, like itself, is equal to 1. So we cancel these out and get x plus 2 over 1. And now, if we plug in the number 2, we get 2 plus 2, which is equal to 4. Holy, my 4 looks horrible. 4 over 1. And then that is just equal to 4. So we were trying to figure out what happens as it's approaching that number, and we already confirmed that if it hit this number, it's gonna be equal to 0. All right. Let's try another one. We're gonna do x is approaching 4, x to the power of 2, minus 16 over x minus 4. Immediately we should be able to see that if we plug in the number 4 here, 4 times 4, which is basically 4 to the power of 2, is equal to 16. So we get 16 minus 16, which is equal to 0. That is a 6, holy frick. And x minus 4. When 4 minus 4 is just over 0. So 0 over 0, this looks like, yeah, that doesn't make any sense. But let's simplify it again. The square root of x minus 16, which is equal to x plus 4, and x minus 4. And then we put x minus 4. Now, do you see something that's the same as other thing in this fraction? I don't mean to sound like Dora, but it's right here. We cancel these two out, and we get x plus 4 over 1, which is equal to, plug in the 4, 8. And that's our answer. Now what if we mixed up polynomials with these fractions? We're going to make it a little bit harder, guys. Bear with me. We're going to put 2. X is approaching the number 2. Then we have the equation x to the power of 2. What the hell is my 2? X approaching 2. Or no, x to the power of 2. And then x is approaching 2. Then we have x squared plus 3x minus 10. And then we put that over x squared minus 2x. Now, what we're doing is trying to simplify this equation before plugging it in. Always remember that. So, how can we simplify it? Well, it's November. We should be thinking about Christmas trees, guys. So now we're gonna make a little Christmas tree, and we're gonna make it negative 10 as the star. Yep. So negative 10. What two numbers can multiply to negative 10 but then if we add them together, we get 3. Well, we have x minus 2, and we also have x plus 5. Because if we multiply negative 2 and 5 together, it equals negative 10. And then if we have negative 2 plus 5, which is just 5 minus 2, we have positive 3. So these two numbers work. And then on the bottom, we have x to the power of 2 minus 2 times x. Now, a common thing that these two numbers and variables have in common is the letter x. So we can also factor it out. So we can factor out an x. So what we're going to do is basically put x outside of the parentheses, and then we have x minus 2. Because, what the x minus 2. So, my bad. If we multiply these numbers, so x times x, we have x squared, and then we have x times negative 2, which is negative 2x, right here. So, once again, we see two things that are exactly the same, so x minus 2 and x minus 2. Let's cancel them out, and we get x as the denominator, and then on the numerator, we have x plus 5. Now let's plug in limit. Always write limit. I kind of forget to do this. Your math teacher might be picky about this, so you have to write this every time, or not, depending if you want to get yelled at or not, or your teacher's cool. But if you have to write it, you put this, and then you plug it in for x. So now we simplified it a lot, so let's put x, or no, we're going to put 2 plus 5 divided by 2, which is equal to 7 divided by 2, and that is our answer. Now, I hope you guys enjoyed understanding how to, or I hope you guys learned what a limit does and how we can see change as a number, as a value is approaching another number. What we can take away is basically the difference between understanding what happens when we plug in 2 as our x variable, and what happens if we simplify it and then plug it in, and then understand that the rate of, like, the changes that happen as it approaches it. Next video we're going to be talking about integrals or derivatives, or we might actually just touch more base upon how limits work, but whatever. Anyway, I'll see you guys in the next episode. Peace.